So this video is an introduction to doing a two-column geometric proof. And I want you to take a second and read the quote that's currently on the screen. Two-column proofs and proofs in geometry in general can be very frustrating. But what they're training you and teaching you how to do is how to get from point A to point B in a logical, step-by-step process, regardless of what you're trying to get to, which is a great life lesson. Yes, they're going to be challenging. Yes, there are going to be times that you get frustrated. But if you stick through it and you persevere, it's going to help your brain grow even if you make those mistakes, just like we've talked about in class. It's ultimately going to help you even outside of the math classroom because we are working on these logical, step-by-step problem-solving skills. So, this is our goal. We're going to take what we've been given or what we've worked on together in terms of congruency statements, why we know things are equal to each other, congruent to each other, and we're going to put logical statements in a row to prove beyond a shadow of a doubt that these triangles are congruent, or two triangles that we've been given are congruent. The first thing that we list is always going to be our given statements, and the last thing is always going to be what we're trying to prove. So these are the things that I want you to think about. All of the steps that we use have to be logical. They have to be in a logical order. Each line in our two-column proof can only address one thing at a time. And as we work through our steps, they have to follow logically in order. Every step has to be true that we're working with in our proof. It has to be a definition, a postulate, or a theorem that we've dealt with in class. And the greatest part is, there's not only one way to get through these proofs. We are going to mostly deal with two-column proofs where we have to fill in the blank. So number 4 isn't as true in the fill-in-the-blank methods, but we will work on some proofs where you're going from beginning to end without anything being given to you. So we're going to try to figure out, based on these pictures, what's hiding behind those blue boxes, which have been whited out on your guided note pages. So if you notice, just looking at the very beginning at the top, without even looking at the proof, we've been given that these line segments are congruent. You'll see that your two triangles have tick marks on them. That shows you visually what that given statement says. So just by what the picture shows me, you notice that I have a side, side, side congruency. So that tells me that at some point I need to see side, 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 or SSS, show up as one of my reasons of why these two triangles are congruent. And my goal is to say that those two angles, M and angle P, are congruent. Well, in my given statements, I don't have any angle information, so I can't prove that those angles are congruent until I have definitely proven that the triangles are congruent. So that gives me a head start into thinking about where I need to go with this proof. So step number 1 in my statements, I've listed that line segment MN is congruent to line segment PQ, which is the very first given statement that they give me. And then I've hidden my next statement, and they said that that's also given. And step number 3, you'll see that OM is congruent to line segment RP, which tells me I've got this line segment already taken care of. I've got the last line segment already taken care of. So that tells me that what's hiding behind this first blue box is that line segment NO is congruent to line segment QR, because they gave us that. They told us in the beginning. And then we go down to step number 4. And it says that triangle MNO is congruent to triangle PQR. Just by looking at my pictures, which line up with statements 1, 2, and 3, I know that they are congruent because of side, side, side. It shows me on my picture, so I know that that's true because of the segments given. So behind box number 5, that is my ultimate goal. So now that I've shown that these two triangles are congruent, why are those two angles also congruent? And we talked about this in class the other day. The reason that those two angles are congruent, given the fact that I've already proven that the triangles are congruent, is because of CPCTC, which tells me that corresponding parts of congruent triangles are congruent. And that's it for proof number 1. All right, proof number 2. So they told us that line segment SU is congruent to line segment UV. And they were nice enough to put those line segments there or the tick marks there for us. So why in the world is SU congruent to UV? Well, that's the given statement. They already told us that. So based on this picture, now if you see in statement number 2, my statement's covered up, but I know that this is true, whatever is hiding here, because of the reflexive property. The reflexive property tells me that something is congruent on one triangle because it also lives on the other triangle. So in that, what that tells me, that reflexive property tells me, is there is something that is shared by both triangles, and that's why I know if I pulled those two triangles apart, that piece would be congruent. So if you look at these two triangles, they share side TU. So I know because they share that side, it has to be congruent to itself. So I have that a side is congruent and a second side is congruent. And I also know that this is a right angle. So what property am I allowed to use to prove that triangle STU is congruent to triangle TUV? And because it's a right triangle, I can say that these are congruent with the hypotenuse leg theorem. And last but not least, hiding behind my prove statement at the very end with CPCTC, is that ST is congruent to VT. We've got one more proof that we're going to fill in the blanks together with. All right, so last one. You see the given statements along the top, and they've given us a picture. They're showing us that these two lines are parallel, which is awesome. We've got that C is the midpoint of AE, and our job is to prove that BC and DC are congruent segments, which tells me I have to prove that the triangles are congruent first. So that's my goal. So given statements, I see that C is the midpoint of AE has already been given, which tells me that the thing hiding between box number 1 is that AB is parallel to DE. And I also know that this is one of my given statements. So the first two, not too terrible. We've got those taken care of. Now they gave me that AB and DE are parallel for a really specific reason, because you and I know we talked a lot about parallel lines. We can consider line segment AE to be our transversal. And if you check out what's going on here in reason number 3, they're telling us that alternate interior angles is a reason that we're using in this proof, which tells me what's hiding behind box number 3 is an angle that I can say is congruent because of those parallel lines. Now, when I'm trying to prove what angles are behind number 3, I need to be really careful about how I'm going to go about proving this statement to be true. So they're giving me angle ACB and angle DEC down here in statement number 5. So ACB is this angle over here, and DEC is this, DCE is this angle over here. So I've got some vertical angles going on that we're going to prove. And if you work backwards a little bit, they're using the definition of midpoint. So because the C is the midpoint, they're trying to say that this line is getting cut in half. So I know I'm proving that lines are congruent. So in my mind, I'm thinking, all right, what statements can I use to prove that these two triangles are congruent? Using a side and an angle. Well, I've got angle, angle, side, and angle, side, angle that I could use. Should probably check out this angle up here. So could I say that BAC and DEC would be those alternate interior angles? And if you kind of tilt your head to the side a little bit, if you want to think about AB being your, whoops, no idea what just happened. Well, you kind of got a sneak preview of what's going on with your proof. So if you tilt your head sideways and make AB the top parallel line and DE the bottom parallel line, it might help you see that I've got those alternate interior angles going on. And like I talked about before, definition of midpoint. All right, so if I'm thinking about what it means to be a midpoint, it means I'm taking a line segment and cutting it exactly in half so that the other two pieces that are created, those two segments that are created, are equal. So that's got to be the two segments that are created by cutting line AE in half. All right. So we talked about angle ACB and angle DCE and where they are on my picture. But why are these two angles congruent? Well, we know that those angles are called vertical angles, and all vertical angles are congruent. So I have an angle, a side, and an angle, and that to us is enough to prove that those two triangles are congruent. So now that I've proven that those triangles are congruent, I can say that those two line segments are also congruent because they are corresponding parts on congruent triangles. All right, so you've got some fill in the blank proofs that you're going to be working on after this video. If you have any questions, shoot me an email or just highlight where your questions are in the proof or where you're getting stuck, and we will work on them together when we get back to class after spring break. I hope you guys have a great spring break, and I will see you after.